Okay friends, welcome to part 3 of our video presentation on chapter 4 that talks about managing the data resource. In this part of the video presentation we will talk about specific principles in managing data, and those principles are spelled out here, and we'll go into more details about each of the principles in a minute. But before we do that, we can start out by visualizing the entire data management process, how this process looks within an organization. One way to visualize management of data is to view data or information as some kind of component or some kind of flow that goes across various layers or various levels of an organization. Now, data is typically generated at the operational level. It's generated by transactions that businesses automate with the help of information technology. For example, transactions with customers, transactions with employees, transactions with suppliers, transactions with partners. So this data is generated by operations. Now, after this data is generated, it is summarized for mid-level management. So basically, this data is transferred to the managerial level, and this is where analysis and presentation is being done. So this raw data is being captured and then analyzed, summarized, so that mid-level managers can make decisions based on that raw data, based on that summarized form of raw data. And then this data is being transferred to the top of the organizational hierarchy, to executives. So basically it means there's a second layer of aggregation of data. So you go from management level to executive level. And then throughout the process of data being lifted from the operational level to executive level, this data can be combined with several external sources, depending on the needs of the organization. So this is like the essence or the general framework of managing data, how data is retrieved, stored, analyzed, and transferred within an organization. Another way to imagine data management or visualize data management is to view organization as a data or information factory. Now, if you think about it, this analogy is not that far off, given that a lot of organizations nowadays, especially service organizations, they're largely driven by data, by information. For example, if you think about a bank, one can argue that banks are largely about passing or transferring information or data back and forth. So, for example, when you come to a bank and you want to apply for a loan, you bring what? You bring your own data, or information about your income, about your employment, about your residential address, all those things are combined by bank process to give you back, again, data, which means, their decision whether your loan is approved or not. So organizations nowadays, at least information-based organizations, they're like data factories. So what happens is that data is constantly being captured, and then, once it's captured, it's transferred to the operational floor. Okay. Now, before it goes into the operational floor, it's subjected to some kind of quality control, meaning missing data is eliminated or being filled in. Errors are corrected. Formatting problems and fixed, and so forth. So after that, after the data is pre-processed, this is transferred to some kind of long-term storage area, like some kind of warehouse. Okay. And this is where the organization itself gets the data from that long-term, storage capacity. Data is being retrieved and then being processed into information, meaning like a form that is usable by specific application or specific employee. And then some of that information can be transferred back into this long-term data storage and this long-term data warehouse. It can also be stored there. So this is how data or information is processed within an organization using this factory analogy. Okay, so now let's talk about specific principles in managing data. First of all, the need to manage data is permanent. I mean, it never stops. Any organization, it's like a huge freight train, going full force, and it's always generating data. And you just cannot stop. I mean, if and to make things more complex, business processes always change, because they change, the software needs to be rewritten, but the data can be reused. So basically, data in a way never loses value, so it always has to be stored, always has to be managed. In fact, there are a lot of organizations nowadays that never discard their data. For example, Google, based on rumors, I guess, is never deleting any kind of search data. So if you've had your Google account or Gmail account for a number of years, and you've been using this account to search through Google search engine for specific topics, now all this data is being stored by the company. So it's like permanently stored. It's never being deleted. So there's always a need to manage data. I mean, it never stops, because organization changes, but even if it changes, you can still reuse the data that is already being stored by the organization. The other thing to keep in mind is that data exists at several levels within an organization. We already said that most new data is captured at the operational level. And then managerial and strategic databases, they typically rely on aggregated operational level. And then, at that level, at mid-level or executive level, some external sources can be brought in. So this information can be combined with external sources to generate reports that are useful for management and executives, for mid-level management and executives. So basically, you need to understand that data or information is different at different levels of an organization. Something that is useful for operational workers may not be useful for executives or middle managers. So in other words, data management needs to be kind of targeted or needs to be customized for every level of the organization. Now, another principle or good practice is to separate application software from the database. Basically, software automates processes, and then those processes may rely on certain databases. Now, we said before that processes change, they can be outdated. So in that case, you write a new piece of software, but you still reuse the old data. Now, in the old days, a lot of applications, they had their own internal built-in data structure. So in that case, a lot of organizations were hesitant to discard their old applications and change their IT-driven processes because they were afraid to lose data. An example of that would be like, let's say you use your browser for several years, and you have your own settings there, and you have your own bookmarks, and because of that you're hesitant to migrate to a new browser because that would mean losing all this data that you entered. Well, fortunately nowadays, if you download a new browser, let's say Google Chrome, it will ask you, would you like to import settings or would you like to import favorites from your current default browser, right? So that can be separated. The browser as an application, as a bundle of processes, can be separated from browser data. Okay, so that's another principle of data management: separating data from applications, from software. Also, another principle is to understand how applications impact data. Some applications are meant to capture data, others are meant to transfer data, and then from one form to another, let's say, and then some applications are meant to analyze and present data. So different applications have different relationship or different use of data, and that needs to be taken into account when designing information systems and managing data. Application, it's kind of related to the previous principle that we discussed. Application software should be considered disposable. It is data that is most valuable, not the application, because once again, processes can change, but the data that you have may still be relevant. I mean, it may be slightly outdated, but it's not a useless resource. So, and once again, there's that growing trend within many organizations. Especially given Sarbanes-Oxley Act, and especially given that IT infrastructure is becoming more affordable, and powerful storage solutions can be built with less money. So because of that, there's this trend of discarding applications, writing new software, but keeping the data intact within an organization. Another principle of data management is that data needs to be captured once. What it really means, it means that data needs to be stored in a central location. There should not be any duplication of the same kind of entities. For example, if you want to store information about customers, then store this information in one central database devoted to customers. Don't distribute information about customers across several functional units. I actually wrote a case study about this. Basically, it was based on my own experience with some furniture stores in the United Arab Emirates. Now, a lot of organizations, one specific organization that I looked at, basically, their problem was that their functions like accounting, marketing, operations, not only they were distributed across geographical locations, those functions also they didn't have a shared data infrastructure. So marketing people would have their own records of customers, operations people would have their own records, and finance people would have their own records as well. And sometimes they simply could not reconcile this data. For example, a certain customer, named Muhammad, which is a very common name in the Middle East, calls the marketing or customer support function to ask about his furniture order. And in order to answer his question, they need to call operations people to see what's the order status. However, the way the name Muhammad is spelled, it can be spelled in a dozen of different ways. So the way it's spelled in the customer service database may be different from the operations database. And because of that, they're not sure which client it actually is. So they have two different names for the same client, perhaps, and they cannot reconcile their records. So duplicating data leads to a lot of confusion and also a lot of data problems, a lot of bad data, but also unnecessary storage cost. I mean, why would you want to store something several times when you can store it once? If you store it once, you'll have simpler, more robust data structure. Principle number 7: there should be strict data standards. How you identify data, how you name your attributes. What are the rules for ensuring integrity and so forth. So typically there needs to be like specific person in charge of data quality and data integrity. That reminds me of my own organization, the university that I worked before. One of our most, it was the most important project that we had was basically AACSB accreditation. Now, as a part of this accreditation initiative, we had to collect a lot of assurance of learning data. Assurance of learning data means data about courses, and more specifically about the degree to which students on those courses achieved the desired learning objective. So that's called assurance of learning data. Now, what we quickly figure out is that we had a serious issue with data integrity, because instructors would report those assurance of learning results using different ways. Sometimes they don't put enough, effort into making sure that the data is current and the data is correct, and So because of that, we had to hire a separate person who served that data stewardship role. So basically, the person title was accreditation, something like accreditation data quality assurance coordinator or something like that. So this person was responsible specifically for looking at assurance of learning data to make sure it's correct, because based on those, this data was a very important component in our accreditation reports. Okay, some specific types of data standards, they're listed here. For example, identifier. What kind of attributes are used as keys to uniquely identify records? Naming. How do you name attributes? What is the naming convention? For example, when I specify names for attributes in an entity, I always make sure that attribute starts with the entity name. For example, if there's an entity called student, then my attribute will be like student first name, 3 words. So student is the name of the entity. So in that case, when I look at this attribute, I know exactly where it comes from. It comes from that entity called student. You need to whenever you create an attribute, you need to keep track. You need to store definitions. In other words, you need to explain in the data dictionary what exactly this attribute is storing. Because when you look at this data structure or data attribute, tomorrow you may not remember. The problem becomes even more complicated if somebody else decides to look at your data and try to do some modifications. So if there are no definitions, then that can never be done, or it can hardly be done. Then you need to specify integrity rules as a part of your collection of data standards. Basically, data integrity rules means like what are the legitimate values for a specific attribute. What values can, for example, for date of birth, it cannot be before than 1900. You don't expect somebody to be more than 115 years old. At the same time, let's say data cannot be, date of birth cannot be younger than 15 years, because let's say whatever you're selling cannot be sold to kids, or 16 years or 18 years. And then, as a part of your collection of data standards, you need to specify usage rights, meaning who has ownership or access to which data. Otherwise, this can create a lot of confusion and a lot of security problems. For example, confidential data may be leaked because somebody who is not supposed to have a view of the data, and I'm not talking like some kind of theft or any kind of deliberate sabotage attempts. Let's say a particular person in PR or marketing was not supposed to look at some of the latest patents of the R&D, research and development department, and this person somehow got a hold of those things, and that person published some PR articles in news papers or magazines, And that can have like a negative, profound negative impact on competitiveness of the company when competitors know what kind of patents, what kind of technologies the company is researching. So usage rights needs to be specified as a part of your collection of data standards. And that's why organizations, they get involved into master data management. So master data management, it's basically, another more common term for that is data governance. So it consists of certain rules and processes and principles for high-level data management or data governance. But collectively, it's called, it's a collection of disciplines, technologies, and methods to ensure the currency, meaning, and quality of reference data within and across subject areas. So we'll talk about data governance in our next and final presentation, Chapter 4. So thank you for listening.